Let's get started with this walkthrough, and there's one important assumption we're making at the very beginning, and that is the switch has just been added to the network. And this brings up another important point. When you first boot a switch, that MAC address table is not empty. There will be some entries for the CPU, and they're going to look something like this. I actually want to show you this on the live equipment because I truncated the output of show MAC address table for obvious reasons here. This is on one of our multi-layer switches, and as you can see, we have quite a few addresses here set aside for the CPU. We've got some dynamic addresses here because I do have some other devices connected to this particular switch, and we'll work with some of those in later labs. But this is what I want to point out to you now, that even if we disconnected everything connected to this one right now, we would still have a stack of static addresses. One more thing I want to point out to you veterans, is the show MAC address table command, period. It used to be a pain because it had 2 hyphens in it. Now it's a pain because it has 1 hyphen in it. Depending on which iOS version you're using, you may have to put show MAC hyphen address hyphen table or dash, however you want to put it. You may have to do that. In later versions, they got rid of the one between MAC and address. That is not going to be an exam topic. They're not going to get that nitpicky. But just a word to the wise there, if you're working with live equipment, one of the simulators, or even on your exam, if you put in show MAC dash address dash table and it doesn't work, just take the one out between MAC and address and you'll be fine. Now let's go ahead and start our walkthrough with A sending a frame to C. Now the frame is going to come into the switch on O/1. And I do take out fast Ethernet on these because I don't think I have to say fast Ethernet O/1 every single time. It's just easier for you and for me. Now, the switch is going to look at the source MAC address of the incoming frame, and it asks itself one simple question. Do I have an entry for this address in my MAC address table? Well, since we just turned the switch on, there's no entry for A's address in the MAC table, so the switch is going to make one. And if we run show MAC address table dynamic at that point, and that's the filter that shows you, of course, only the dynamically learned MAC addresses, then we would see one for the all A's address off O/1. Good enough. Now, at long last, we get to that frame forwarding decision. Will the frame be forwarded? Will it be filtered? Or will it be flooded? Well, that depends. That depends on the answer to the next question the switch asks itself, which is, do I have an entry for this destination address in my MAC address table? Well, the answer here is no. There's no entry here for the all C's MAC address. So the switch does what we call flooding the frame. And when you flood a frame, the switch sends a copy of the frame out every single port on the switch except the port the frame wrote in on, so to speak, the one the frame came in on. A switch is never going to send a copy of a frame back out the same port it came in on. Now, what we call this is an unknown unicast frame, and that's such a great name because when I first read that years ago, again, I always thought, well, if it's a unicast, then how can it be unknown? And what we mean by this is it is a unicast frame and it has a unicast destination address. There just isn't an entry for it in the switch's MAC address table. So this is what ends up happening again. We get an unknown unicast from A to C, and it's unknown to the switch because the switch does not have an entry for C's MAC address. And in this case, that frame will be flooded. It will be sent on every port except the one it came in on. Now, there's good news and there's the bad news. The good news is that flooding ensures the frame is going to go out the port leading to the correct host. And that's what we want, right? Right. But it also guarantees that every other connected host is going to get the frame, which is a humongous waste of bandwidth, switch resources, and even host resources. Because if this is a 64-port switch, and there's a host on every port, the switch is going to get the the unknown unicast coming in on one port. It's then going to send a copy of it out 63 ports, and 62 of those sends are totally unnecessary. Now, there's nothing wrong with a little frame flooding as you add hosts. You know, that's natural. That's going to happen. It really can't be avoided. But after that initial add of a device, we really want to keep flooding to a minimum. And you can certainly see why here. Now, C now responds to A with a frame of its own. Is there an entry for the source MAC address of that frame? Well, there isn't, because we know at this point the MAC address table only has the address of host A. There's no entry for host C, so the switch creates one, and now we have dynamically learned MAC addresses just that quickly for devices A and C. And the dynamic entries in the table now start to work in our favor, because the switch will now check for the frame's destination address of all A's, and there is such an entry. So the switch will forward the frame out 0/1, the port leading to host A. And again, if we had 64 connected devices to this switch, then how many ports would we be sending that frame to? We'd be sending it to 1. And that's it. We don't have all that unnecessary flooding. Now at this point, the switch has MAC address entries for A and C. And frames going from A to C now, they would be forwarded out 0/2 only rather than being flooded as they were initially. So just that quickly, again, you have a little initial flooding, that's okay, but that's where we want it to end. Now I want to move ahead to a scenario where the topology is going to be the same, and the switch has a dynamic MAC entry at this point for every host. And here's the giant disclaimer. I don't have many disclaimers in the course. This may be the only one. Please note this is not a topology you're going to see in production networks, if ever. I'm presenting it to you strictly to illustrate the switch's third option for frame forwarding. And at this point, we know, and excuse the gap there, we know that A and B are connected to the hub. And the hub is connected to a switch. Okay, so we've got that back on the screen. We see that. Well, from the switch's point of view, both A and B are found off port 0/1. When A sends a frame to B, B is going to get a copy of it through that hub, as will the switch. So the switch is going to do what? It's going to look at the source address first, then it's going to look at the destination address, and it's going to say, wait a minute, what's going on here? Well, what's going on here is that the switch's MAC address table shows that host A and host B are both found off 0/1. So the switch just goes, okay, what's going on here? Well, it messes with the switch's mind for just a moment. And then the switch will simply filter the frame. And filter is a fancy networking way of saying we're dropping the frame. That's it. It's just that simple. That's really the only time you actually see frames being filtered in a situation like this. Now, I want to review these decisions with you and add a little bit of broadcast multicast discussion to go with it. Flooding, again, it occurs when the switch has no entry for the frame's destination MAC, and when a frame is flooded, a copy of it goes at every port on the switch except the one it wrote in on. Unknown unicast frames are always flooded. Now, frames with a destination MAC of all Fs, and they could be lowercase f's, uppercase f's, doesn't matter. These are broadcast frames, and they're treated in the same manner as unknown unicast frames. And broadcast frames actually are intended for all of our hosts, and unknown unicast frames are sent to all hosts. It really is a side effect of the frame flooding. Now, with multicast frames, I want to bring those up too. They have a destination MAC in the range 0100-5E00-0000 through 0100-5E7F FFFF. I think that's a good range for you to know. And they're treated the same way as broadcast frames are. Exact same fashion. Forwarding, we know that happens when the switch does have an entry for the frame's destination MAC, and forwarded frames, of course, are sent out only the port indicated by the MAC address table. Filtering occurs when the source and destination MAC addresses are found off the same port, an exceedingly rare situation in today's networks. And also, filtering technically occurs when a frame is not sent out a port because the destination is a known unicast. I don't see that usage of it a lot, but I see it once in a while, so I just want you to know about it. And let's see more about that MAC address table. We're going to talk about this on the very next video and look at some commands on the live equipment. So take a breather. I'll see you on the next vid.